comes out and goes, "You can't see the curvature. He had a beach ball globe, and he goes, "You're 2 millimeters over this. That stuff is flat." Again, a poke in the eye, right? That stuff is flat from that point of view. So they just keep moving the goalpost again and again and again. But so they want you to believe you can't see the curvature. But then the next best proof is they want you to believe that boats go over the horizon. Okay, that you can see a boat over the horizon. So now using globe math, right? Not flat Earth math, globe math. Okay. Do you know how much curvature there is at just 3 miles? If the Earth is 24,901 miles around, like the globe tells us, globe believers don't know that number. Flat Earthers know that number. Okay.
Yeah.
Okay. There's 6 feet of drop at just 3 miles. So when you're standing at the edge of calm water, perfectly calm water, not a ripple or swell, and you're standing up and you're 6 feet tall, you should not be able to see the surface of the water beyond 3 miles because it's 6 foot drop. So now you have your curve, right? My mouth is behind this curve. It's a physical curve. Zooming in isn't going to help bring it back in, right? Because it's a physical curve. A globe Earth requires a physical curve at X distance. Now, if there's waves, right? If there's waves, that's going to bring the apparent horizon closer to you. Okay. And if there's a fog or any type of atmospheric density, that's going to bring closer. And if you sit down, that's going to bring the horizon like to less than 2 miles away from you. Now, if you're watching a sunset on California, does that sun look like it's intersecting the water a mile or 2 or 3 miles from you? No, it looks like it's way out there. So what are we seeing then, right? So here is, you don't see any boats out here. We zoom in and all of a sudden we increase the angular size of these boats and we can see them. Now, are these boats partially hidden behind the curve of the Earth or are there just swells in their way? Look at this boat. It appears, disappears. Now, is that over the curve of the Earth? No, it's just behind what we call an artificial horizon. Can my finger hide my entire face?
No.
What if it was closer to you?
Mm-hmm. Mm-hmm.
Okay.
Wow.
So these waves in the foreground will hide a boat in the background. And the Globers say, what about big ships, right? And then you look at you just understand that waves just a couple miles out, a big ship gets smaller and smaller and smaller in the distance. So not only could that 1 or 2 foot wave hide that entire ship, it could hide an entire city in the distance because things get smaller and smaller and smaller in the distance, right? Once you understand that, then you'll understand, people are like, what, are the waves bigger than the ships? No, my finger's not bigger than my face. Okay. Right. So on the app, on the frequently asked question page, on the boats over the horizon button, there are a ton of videos that YouTube is hiding from you. Google's hiding from you. You'll never find them unless you know the channel name and the exact title. But if you go to Boats Over the Horizon, watch those videos. And that's what I did. When I watched all these videos about the boats over the horizon, I went out and bought a Nikon P900. I spent like $1,000 on the camera and tripod, went down to the beach, sat down at the water's edge on a beautifully clear, calm day. And I zoomed in on stuff that should have been 60 feet below the curve of the Earth. 60 feet.
What's the measurement at 60 feet?
No, 60 feet. At 10 miles, there's 66 feet of curvature. So know what I did? I didn't just believe that. I said something's wrong with the curve calculator. Earth is a globe, and this curve calculator is wrong. So I went to looking for what's the proper curvature of the Earth, and there's 3 formulas. There's 3 different ways to derive it, and one of them is the easiest, which is 8 inches. excuse me, 8 inches per mile squared, based off of the Pythagorean theorem, and I said that's got to be wrong, because I can see this stuff. And of course, the Earth is a globe. So I went to the debunking sites, and the debunking site said, well, that's not how it works, right? Because you think you're here and the drop is here. But in reality, you're here. There's a hump and a drop. So it's only half that amount, right? And I thought about that and I'm like, that's ridiculous. But let's use it. There should only be 33 feet of curvature. I could see buoys on the water with water beyond them. Where's the 33 feet?
Right.
Okay. So that's the first thing that really kind of brought me in. I'm like, and then I was like, well, what about refraction? And when you look, these things aren't refracted. Okay. They're not refracted. And the best thing the Globers have is they take like a basketball and they put like, I think it was like a little red piece of yarn right over the horizon of the basketball. Then they poured liquid nitrogen on the basketball, and the orange or the red, whatever the thread showed up, like the color showed up for a second. Okay. That's the best that they have.
Yeah.
But how do you pull cities up like Chicago across Lake Michigan where it stays there all day? Okay. We can see it, all day. Here's a time. Everyone's seen this famous picture. Okay.
Mm-hmm.
But here is a time lapse where now you can see the Chicago's right here. This is I think it's like a close to 24-hour time lapse. So you have temperature changes, lighting changes, right? The buildings are still exactly right here. They're not moving, right? Not moving. And then at nighttime and the lights will come on, right? And these buildings are here. They're not a mirage. That's all time lapse. Okay. But here's one that really that I like. Okay. And it is a Glober will say this. A Glober will say, I can't see. I'm in Malibu and I'm looking Mount Jacinto, San Jacinto is 123 miles away. How come I can't see it? Well, you can't see it because it's below the curve. But then you put on an infrared lens and all of a sudden you can see it, right? At that distance. This 7,000-foot mountain should be all of it except maybe the very tip should be below the curve. But there it is. Take off the infrared, blue sky. It's a blue sky, and all of that you can't see. This is how our vision works. It's like looking through an Olympic length pool of pristine clear water. You can't see the far end of the pool, right? It's just like looking
because of atmosphere and all the other
the atmosphere becomes sky. The atmosphere over distance becomes opaque, and we call that sky, right? So let me ask you a question. Can you guys see me? You see me?
Yes.
You actually see me? Or do you see the light that is bouncing off of me?
Right. The light that bounces off you.
And now how could I prove that? Turn off all the lights in this room, you wouldn't be able to see me.
Mm-hmm.
Right?
Right.
So the light that's bouncing off of me has a certain brightness to it. The light that is coming at me from the light source, I got a nice big light right here. It's brighter than the light that's bouncing off of me, right? It makes sense. Light, right. It diminishes, bounces off. So here is Mount Canigou, okay? From a viewing spot in Aluja, France. And the sun migrates to the Tropic of Cancer, Tropic of Capricorn, 6 months out, 6 months in. Twice a year, it lines up with the viewing spot and Mount Canigou, okay? And you can't see Mount Canigou because the top of Mount Canigou should be over half a mile below the curve. Half a mile below a physical ball curve, okay? Right? So the light that's bouncing off of Mount Canigou isn't bright enough to push 175 miles to your eyes. So you just have sky. However,
it makes sense.
The light source from the sun is much brighter. It can push through much farther, but not forever. And when it lines up for those 1 or 2 days twice a year, there's the entire mountain range. The very top right there should be over a half a mile below the curve. Global argument is it is below the curve. The sun is already set, but it's refracting up and it's not really there. It's magically stopping at eye level. And all of the places in between are refracting their separate distance, all to line up to make it look like a flat plane. This is what they say. And people are like, well, it's a globe, so that must be true. The globe is an assumed situation that they just base everything off of. Eratosthenes assumed the Earth was a globe. And so he did his calculations and said globe. But those calculations work perfectly on a flat Earth. Right?
Wow.
Yeah.
Irrefutable, as far as I can see. Brian, do you have a question?
It's quite fascinating, actually. So see, I did not I didn't. I looked very briefly at your website, but I said, you know what, I want to hear it from you. You'll explain it better than me seeing it on the website.
Okay.
And I didn't look up counter arguments or anything like that because I wanted to come into this with as much of an open mind to kind of be able to ask you questions, almost like a teacher and a student kind of thing. So I heard you mention briefly, the view from an airplane and the view from, let's say, the guy, the Red Bull guy jumping out. So I guess at 30,000 or 50,000 feet, if the Earth was a globe, you would not see the curvature then?
So here's a balloon at 127,000 feet without a fisheye lens. You watch the whole video. It shows a flat horizon. But the other problem is, one, is that sun 93 million miles away? If it is, how come it has a hot spot in this local area below it? When 93 million miles away, it just light up everything equally. Okay. And it doesn't. It's right there. This is clearly a local light. Now, the other thing is, the problem is the Earth is spinning 1,000 miles an hour below this balloon, which is disconnected. All right. It's in the thinnest part of the atmosphere. So when it comes down, the Earth is spinning to the east. So it should land, 3.5 hours up there. It should land at least 3,000 miles to the west. Guess where it landed? To the east of where it took off, maybe 50 miles. Okay.
Right. Like you'd have to be going on an angle.
Right. So
or something.
The Earth is spinning like this. Okay. Right. So the balloon goes up, the Earth is going to spin out. Right.
Right.
It didn't. The balloon went up and then it landed east. Kind of like the Earth isn't spinning.
Right. Not
That's
moving
crazy,
at all
right?
from some of this evidence.
Where are you guys located?
Well, funny point, actually. If you hold up your globe, I think we're not going to be able to believe in Canada either anymore.
Why is that? Oh, because of green?
Because of the green screen.
Yeah. I bought markers to fill in all the green. I just haven't done it yet.
So now I don't know if I can believe in Canada anymore, even though I'm here. It's a belief.
Well, that's another meme that you might come up with. Flat earthers don't believe Australia exists. No, we absolutely do believe Australia exists. Right?
So I'm in Alberta. So I'm in Western Canada.
Yeah.
Yeah, I'm in more Eastern Ontario.
So here's something, right? So in the summer, in June, when the sun sets, how long is it still light outside? You're having a barbecue, you watch the sunset. How long is it still light?
Well, June 21st for me, I have 16 hours roughly of daylight, and the opposite.
That's not what I'm talking about.
Yeah.
I'm not talking about that. I'm talking about after sunset. How long is the sky still kind of light?
Quite a while.
Here in Connecticut, it's almost 2 hours.
Yeah.
Right. So it's probably close to that to you, 90 minutes to 2 hours.
Yeah.
Okay.
Yeah.
But now, what is it now? It's October. When the sun sets, how much time after the sunset do you have? It's a lot less.
30 minutes, maybe?
Yeah, 30 minutes. And in December, it'll get darker even faster.
Right.
Okay. So now, if you live on a spinning globe, right, it's tilted. 6 months later, the southern hemisphere should have the same lighting effects that we have at equal latitudes. So in our summer, in June, the sunlight lingers. In our winter, December, the sunlight lingers. It lingers less. It's much quicker to dark.
Less. Yeah.
Sunset to dark is much faster. There are places in the South in December that literally in 5 minutes it's pitch black after the sun goes down. Okay, so that should be the opposite for people in the South at an equal latitude. Somebody in Southern Australia, equal latitude to you or whatever, or to me, should have the same lighting. Not true. What happened now? Everybody has different amounts of lighting depending on your latitude. Okay, sunrise, sunset, but from sunset to darkness, the entire world has faster darkness now through December. And then the entire world has lingering for different amounts of time, but lingering wherever you are. In June, you'll have the longest lingering light, no matter where you are. And in December, you'll have the least amount of lingering light. Now, let's look at that on a flat Earth and see why that would be. Okay. So here we are. And let me make this a little bigger. Okay, I'm gonna go off the screen. So if you look at the inner yellow line, that's June, the Tropic of Cancer. And the outer yellow line is the Tropic of Capricorn. So let me go forward: October, November, December. So in December, the sun is all the way out over the Tropic of Capricorn, Australia's summer. Okay. Australia's summer. With me?
Yeah. Yeah.
Let me come back here. Yeah, I'm back. I'm back. So Australia's having the summer because the sun went right over them. Okay. Now, if we took those yellow lines, the inner one and the outer one, and we pulled them off the map and we snipped them and pulled them out, the Tropic of Cancer is much shorter than the Tropic of Capricorn. So the Globers come out and say, how do you explain the sun going faster over the Tropic of Capricorn? And the answer is, well, if you look at the arm on this watch, the tip of the arm is going faster than the inner part of the arm, but it's going around at the same rate. The angular speed is different from the linear speed. Okay. So because the sun is moving faster, it's not going over a curve that causes day and night. It's going away, and the sun is a local light and it takes its light with it. So when it's out here going much faster in December, everyone in the world experiences faster sunset to dark. And when it comes all the way in June, everyone has a longer lingering light because the sun is moving away slower, right? When I talk about lingering light and taking its light with it, let me show you a quick sunset. Where is it? Where is it? There it is. Okay, so this is me with my drone, and the sun is up high in the sky. And if we were on a ball, it would just go down, 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 and it would just keep on going, right? And it would always go at the same rate, 15 degrees per hour. Okay. Mm-hmm. But it's super clear day, super cold, no humidity. The sun went down, 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 and it stopped. And it just sat here above this apparent horizon, right? It sat here. This is sped up 2,500 speed. Okay. What's going on? I'll repeat over here. Okay. It just didn't have the power to push through anymore. So it took its light with it. Its light is local, the local light, and it just went away. Now, when I put this up, man, the trolls went crazy. You're Photoshop, this and that, blah, 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 right? So I did it again, and I did it again, and I live streamed it. Okay. And I have the high def files. People are like, well, how come no one else has ever seen this? How come you're the only one? I go, well, at the time, I may have been the first, because to do this, one, it has to be a super clear day. Very few of those with all the stuff that's going on in the sky. Two, it has to be no humidity, so it has to be below freezing, basically. Three, you have to have a drone with a 4K camera and be willing to heat the batteries so they don't freeze, and send it up and watch the sun when it looks like it's already almost gone. Okay. And then you have to bring it into your editor and zoom in on that tiny little area so you can see what's going on. Okay. And so I'm the only one crazy enough to do that. Now, a lot of people have done it. It's been done a whole bunch of times. There's a whole section on the app that'll show you a whole bunch of these. And then you understand that the sun is a local light.
So, okay. Can you explain? So you're saying that it's going away from us as opposed to down. Is that what you're saying in that regard?
I am, and thank you for asking. Okay. So remember learning about perspective in school?
Yeah.
So here's our perspective grid, and I'll put a guy in here. So his eye line is right there. The sky comes down, the ground ramps up, right? So if I pop this mountain in front of him, what can we say about this, right? We can say the top of this mountain is thousands of feet above where he's standing. That's we could assume that. Okay. The sun is higher than the mountain.
Correct.
Right. And so imagine if you're on a street, it's 12 noon, the sun is directly above you. Across the street is a 10-story building, and the sun is moving away. You're watching it. You're sitting, let's say you're watching a parade, whatever. Okay. And the sun moves beyond the building. Now you can't see the sun, right?
Right.
Is it below the horizon?
Well, we don't know that.
Well, no, you do know that it's not because it's just behind the building. You just saw it go, and your common sense
Right.
will tell you, no, it's just blocked by that building. Now, how could you see it again? Well, you can climb up higher than the building, or you can go backwards a mile, and the top of that building will be at your eye level, right? So if we took this mountain and we put, no, so here's the sun going away. So it's like the building, it's beyond it. It's not below it, it's beyond it. And we move the building, we move the building or the mountain away, right? Fill in the sides, fill in the foreground. What can we say about this image? The top of this mountain is thousands of feet above his eyes.
Right.
And the sun is way above the mountain. But to him, he sees the top of the mountain appears to be at his eye level. We push the sun a little farther, and it looks like it's going down. It's just going beyond. Now let's add the sky into that. And so now we have clouds. And we look up at the clouds. These clouds are all at the same level, but they all merge into this eye line horizon again. Okay. And even if there wasn't clouds, the atmosphere over distance becomes opaque and it merges into this horizon, this optical horizon, the horizontal eye zone. It's the limit of your vision. Okay. So what can we say about this picture? So first, we'll move the sun away and it's going beyond. What's it going beyond? Well, the top of this mountain is thousands of feet above his eye level. These clouds, atmospheric level, is thousands of feet above the mountain, and the sun is above that. It's just going beyond. It just goes beyond. That's it. And we
Well, that's
see
a great
it.
explanation.
Yeah. And let me just show you. We'll add one more thing on here. See if I can find it real quick. Here, I'll show you this. So this is how perspective works. Okay. So I set up this. This is my flat earth kitchen. I got my counter and I have this line and where this is the path of the sun and I'm moving it along. Now this could be mountains. It could be cloud deck, whatever. We're just above it. Okay. And I'm showing you from a terrestrial point of view, a camera at the height of the sun, that this is a straight line. Now I'm a celestial point of view. I have a terrestrial camera on the counter